Okay, let's go on. Operational amplifier, output impedance. Here it was capacitive, resistive, inductive, resistive, capacitive. So that is a lot of fun to model this, and some of you did it already. Here you have the gain and the phase characteristic. And you see here you have the gain, and here you have the phase. And we can map this on a small signal model for SliCap. And here you see my small signal model, including the common mode and differential mode input voltage. And I put here a 1, 0 and 2 poles to make this characteristic. And here is the output impedance. It turns out later, that's why I would like to show you that later on, that this model is more accurate than the macro model provided by Texas Instruments. So this is the model, the SliCap statement for the model. The voltage gain, this one, with this pulse and 0, and the output impedance, just in another form written than the whole circuit, and the input capacitance and the input conductance, which is 1/20K. For noise and bias, we can use different models for SliCap. You see here the offset and the bias current. So the bias current can be maximum, but this is over a huge temperature range. So you can also use the typical one for 60 nanoamps. And we can use this model and use these numbers for the evaluation, and I did. Then the noise. For the noise, we are not going to put the noise in the small signal model. No, we are going to make a noise model, which is a nuller with equivalent input noise sources, because over the operating range of interest, we want the operational amplifier to behave as a nuller, and we study only one of its effects, which is the noise. And then you can see the noise here. It's like the floor noise is 1.1. I took 1.2. We have 1.1 nanovert per square of hertz. You have to square it, which makes it 1.2 times 10 to the power of minus 18. And the current noise density is like the floor noise, 1.7 picoamps. And if you square it, you get this. So we have noise models, we have models for DC variance, and we have models for the ASC behavior.